Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at some examples on how to find the volumes of prisms, pyramids, cylinders, cones, and spheres. Don't forget, we have some practice problems at the end of this presentation for you to try out to demonstrate mastery of the contents of this presentation. All right, to get us started, let's go ahead and review the formulas for finding the volume of the different solids that we're going to be looking at. So the first solid is a prism. Okay, so what is the formula for the volume of a prism? The formula for the volume of a prism V is equal to big B times H. All right, big B represents the area of the polygonal base. Remember, prisms have two congruent polygonal bases and then parallelograms as the sides. All right, and then big H represents the perpendicular height. Between the bases. All right, next solid we're going to be taking a look at finding the volume of are pyramids. They have polygonal bases and their sides are made up of rectangles that all meet at a point on the apex or top. So the volume of a pyramid is given by V equals 1/3 the volume of a related prism with the same base polygon and height. So 1/3 B times H. Okay, so if you have a pyramid with a particular polygonal base, and then you have a prism with identical polygonal base and the same height, the pyramid will be 1/3 of the volume of the prism. Okay, so big B is the area of the polygonal base, and then big H in this case is going to be the perpendicular height because you have some pyramids that slant, right? So in that case, you're not looking at slant height, you're looking at the perpendicular height from the base to the apex. You see the difference, right, between this and the prism. The prism is the perpendicular height between the bases, right, the congruent bases, and then the pyramid is the perpendicular height from the base to the apex. All right, for a cylinder, that's the next one we're going to be looking at. The volume of a cylinder is similar to that of a prism. The volume V is equal to big B times H. All right, but it's a circular base, so if we find the area of a circle, this formula can be extended into big B is pi r squared times H. Okay, so big B for a cylinder is the area of the circular base and H is the height. For a cone, it's similar to that of a pyramid, right? So cone, the volume of a cone is 1/3 of the related cylinder with the same circular base and perpendicular height. So the volume is 1/3 area of the base times height, but for a cone is circular, right? So the big B in this particular case for cone is pi r squared. Okay, so 1/3 pi r squared, which is the area of base times the perpendicular height. And then lastly, we have a sphere, just like a ball. The volume of a sphere, V, is equal to 4/3 pi times radius cubed. Okay, so let's take a look at some examples. All right, so the instructions for the problems that we're working on, for these ones, we are to name the solid, then find the volume. All right, so for question number 1, what kind of solid is this? You notice we have two identical polygonal bases. On the top and the bottom is a 6-sided polygon. A 6-sided polygon is a hexagon, okay? And then the sides are all parallelograms, namely rectangles. So this particular solid is a hexagonal prism. Okay, so we have a hexagonal prism here. Let's go ahead and find the volume. Volume for prisms is area of the base times height. So in this particular case, big B is the area of the hexagonal base. What is the area of a regular polygon? This is a regular hexagon that we have here. The area of a regular polygon is given by 1/2 half of the apothegm times the perimeter, or 1/2 apothegm times the perimeter written as the number of sides times the measure of each side. Okay, so let's go ahead and generate the shape of the base. All right, so there goes your hexagon right there. So if this is a hexagon, the measure from the center to the midpoint of a side right here, that perpendicular distance, which is 7.8, that is known as your apothegm. Okay, 7.8 is your apothegm. And the length of each side, in this case, is 9 centimeters. That's your S. Since it's a hexagon, the number of sides is 6. All right, so with all that piece of information, we can find the area of the base, the hexagonal base, P. So that's going to be 1/2 of the apothegm, which is 7.8, times the number of sides, which is 6, multiplied by the length of each side, which is 9. All right, so let's calculate what that is. We can plug that into our calculators. So we will have 1 divided by 2, or you could put 0.5. 1 divided by 2 times 7.8 times 6 times 9. So we have 210.6 as the area of the hexagonal base. Okay, so big B is, what was it again? 210.6 centimeters square. Okay, so to find the volume, we need to multiply the area of the base times the perpendicular height. In this particular problem, the perpendicular height is how tall was the perpendicular distance between the congruent polygonal bases, and that's 5. So big H is 5. Okay, that's the perpendicular distance right there. So big H is 5. All right, let's rewrite the volume formula. V is big B times H. We know big B is down here 210.6 and H is 5. So we just multiply them together, 210.6 times 5, and that will generate the volume of our hexagonal prism. All right, so let's calculate that. 210.6 times 5, 1053 centimeter cube is our final answer. So let's go ahead and box that. Move on to the next problem. All right, let's take a look at the next question, question number 2. So let's go ahead and name this solid first. We notice that it has an apex right here, a peak or top. So it's going to be a pyramid of some sort. Okay, so let's name it. Just look at the shape of the base. This is an equiangular quadrilateral. So that's a rectangle, okay, because the side lengths are different. So this is going to be a rectangular pyramid. Now, what's the formula for the volume of pyramids? The volume of pyramids is 1/3 area of the polygonal base times height. So big B in this case is going to be area of the rectangular base Okay. What is the area of a rectangle? The area of a rectangle is length times width. So this is the length right here. and this is the width. It's pretty straightforward to see, so that's going to be L times W. All right, so we're going to be looking at 4 times 5 for the area of the base. The area of the base of this solid is going to be 20 square feet. Okay, so that's the area of the base. Next, we need the perpendicular height from the base. See, this is a base right here, all the way to the apex, and that's 5. So this is big H. So big H is 5. So now we can find the volume. The volume is going to be big B. I'm sorry, 1/3 big B times H, just to rewrite it. So it's going to be 1/3 of big B, which is 20. That's what we found earlier, times 5. Okay, so when we work this out, it's going to be 100 over 3 feet cubed, which can be approximated as 33.33 repeating cubic feet. So there goes the answer to question number 2. Okay, let's move on to the next one, question number 3. All right, so what kind of solid is this? This right here for question 3 is a cylinder. Okay, so let's name it. The name is a cylinder. All right, how do you find the volume of a cylinder? The volume of a cylinder is big B times H, which can be further simplified into pi r squared, the area of the base, times the perpendicular height. In this particular problem, this value right here, the distance between one end of the circumference to the other through the center, that chord is known as the diameter. Okay? So if D is 18, then the radius is going to be half of that. 18 over 2, which is 9. So in this particular problem, R, the radius is 9. And the perpendicular height is the height between the two circular bases. So this is a base, that's a base. The perpendicular distance between them is 11. All right, so H is equal to 11. So your volume is going to be pi times the radius square, 9 square, times the height, which is 11. And then when you work that out, 9 squared times 11 times pi with your calculator, you're going to get 891. So V is going to be 891 times pi. You put a number first and then a rational number pi, inches cubed as your exact answer. If you want to round it up into 2 decimal places, it's going to be 2,799.16 inches cubed. Okay, so if you want to see that with a calculator, just type in 891, which is 9 squared times 11, times pi, and then hit enter to 799.16 to the hundredths place. All right, so there goes the answer to question number 3. Let's go ahead and box that. All right, let's take a look at the next example, question number 4. All right, so for question number 4, what's the name of this solid? This solid that we have right here is a sphere. Bam, bam. All right, the volume of a sphere is given by 4/3 times pi times the radius cubed. In this particular setup that we have right here, the radius is 11.9. Okay, so the volume is simply going to be 4/3 times pi times 11.9 raised to the 3rd power. And then if you plug that into your calculator, you're going to get the volume is approximately two decimal places. It's going to be 7,058.78 meter cubed. Okay. All right. So let's just go ahead and enter it into the calculator for you to see. So we have 4 divided by 3 times pi times 11.9 raised to the third power. And there you go, 7,058.78 to 2 decimal places. That goes your answer to question number 4. All right, let's take a look at one more example. So in this particular solid that we have right here is tilted to the side, number 5. What kind of solid is this? This right here is a cone. All right, you have a circular base right here and an apex and a curved side. So that's a cone. The volume of a cone is 1/3 b times h, just like a pyramid, but in this case the base is a circle, so it's going to be 1/3 pi r squared times the perpendicular height h. Okay, so let's go ahead and figure that out. In this particular setup that we have, the radius is 7 and the perpendicular distance from the base, the circular base, to the peak or apex is 14. All right, so plug that into the volume formula. We're going to have 1/3 times the let's do this. Volume is 1/3 times pi times the radius square times 14. Okay, and then we can work this out. If we multiply 7 squared times 14, 7 times 7 times 14, that's 686. So in the numerator, 7 squared times 14 is 686. So we're going to have 686 divided by 3 pi kilometer cubed as the exact volume. And then we want to round it up to 2 decimal places. We can just enter it into a calculator. So we have 686 divided by 3 times pi. And then we get 718.38. So it's approximately 718.38 kilometer cube for the volume. Okay, so there you have it.